All right, so welcome back for part 4 of section 9.1. Let's hope that this is the last section of this, because this one's getting kind of long. All right, so in this section, we're going to take a look at weighted means or in this video, I guess I should say, weighted means and means of frequency distributions. Okay. All right, so the idea of a weighted mean is asking the question, what if I have data, but the values of the data are not consistent? The values of the data have different weights, and the weights, kind of a misnomer here. Don't think of weight as how heavy something is, but like the weight as in it has a different value. And what if I wanted to find the mean of a data set whose entries have different kind of values? Right? I got a formula for it. I got a weighted mean formula. The weighted mean formula says that the weighted mean is given by this formula, where we still get our x bar, and our numerator is the sum of the x's times the w's, where the w is the weight of each entry, and our denominator is the sum of the weights. So downstairs, that's just the sum of all the weights, whatever those weights might be, and our numerator is the x times the w, and then add all those up. Right? It might make a little more sense after we do an example. One that you probably have experienced before, maybe you've never calculated it, but let's say that you wanted to find your grade point average, your GPA. Now, your GPA by definition is a weighted mean because different grades are worth different values depending on the credit hours of the course. For example, if you were to get a C in a 3 credit hour course versus getting a C in a 4 credit hour course, well, both of these are C's, but the second one has a higher weight because it has 4 credit hours, whereas the first one has less weight at 3 credit hours. Okay. So to find my GPA, to calculate my GPA, my grade point average, what I'm going to have to do is I'm going to have to take the sum of all the grades times the credit hours, their weights, and then divide that by the sum of the credit hours. So that's how that's going to look. Okay. The only problem is I can't multiply a d times a 1. I need numbers over here. So the standardization, the standard grade point scale, would be to give numerical values to these. Like a C is a 2, a C is a 2, a D is a 1, an A is a 4, a C is a 2, and a B is a 3. So then when I calculated my GPA is going to be that 2 times 3 from that first class, plus the 2 times the 4 from the second class, plus the 1 times the 1 from the third class, plus the 4 times the 3 from that fourth class, that was my A class, plus the 2 times the 2 from the next one, and then finally ending up with 3 times 3. And then my denominator just needs to be the sum of the weights. In this case, our weights are our credit hours. And then I'm going to go ahead and calculate this. I'm just going to do some simplification up here. That's 6, that's 8, that's 1, that's 12, that's 4, that's 9. 9 and 1 is 10, 12 and 8 is 20, 6 and 4 is 10, so it looks like we're looking at 40 in our numerator, over, let's see, 3 and 3 is 6 and 4 is 10, and then 2 and 1 and 3 is 6, so 16 in my denominator. And then 40 divided by 16 is at, let's see, that's 20 over 8. That's 10 over 4. That's what? 5 over 2, so that's 2.5. So I have a GPA of 2.5. Better raise that if I expect to get any sort of scholarship or anything. All right. They want to see something a little higher than a 2.5. Now, I know what at least one of you is wondering out there. Hey, that's a lot of work, and I'm lazy. I don't want to do it. Is there a way to do it here? There is, and I'll walk you through how to do it. We'll take a look at how it works out. Right? First thing I need to do, though, is I need to take this data set and this data set and put them into my calculator. I'm going to put my grades, my X's, according to the formula, up here into list 1, and I'll put my weights into list 2. So just like I put data in before, I'm going to press Stat, go to Edit. I got junk in there I don't want, so I'll go up and clear it out. Okay. I've got a 2, and a 2, and a 1, and a 4, and a 2, and a 3. Okay. Now here's where you have to be careful, is I got to make sure these line up. So that first tube was with a 3, and then a 4, and then a 1, and then a 3, and then a 2, and then a 3. So the left-right here has to match up. Because if I mess that up, my calculator won't put the proper grade with the proper credit hours. It won't put the proper X value with the proper weight. Okay? But now that I've got that in, I'm going to tell the calculator to find that for me. So I'm going to go back to Stat, over to Calculate. I'm calculating one variable stats, and I have a list, and I have a frequency list. Now it's calling it frequencies, but frequencies, weights, frequencies, we can kind of use those interchangeably. So it's asking me for my list, that's my X's. It's asking me for my frequency list, that's my weights, that's list 2. And then I'm going to go ahead and calculate, and you'll see that it gives me an X bar, a mean of 2.5. Same thing I got by hand. In this problem, it wasn't that much work to do it by hand, but if I had several semesters worth of grades, maybe it might get too much to do by hand. Okay? That's a weighted mean. We also sometimes run into frequency distributions where we need to find the mean. Okay? Now, the way that we find the mean of a frequency distribution is we're going to use this formula right here, where we're going to say that X bar, the mean, is equal to the sum of the X's times the frequency divided by N. Okay? Now, this N in the denominator is our total number of data points. Ooh. Okay. This X here is each individual data. And then that frequency is the frequency for that data point. Yes.
Hello.
Hi, how are you? I was starting to think maybe you weren't going to show.
Oh my God, sorry.
That's okay. Sorry about that. Had someone come by and knock on the door. All right, so we're here. We're finding the mean of a frequency distribution. I know that I got a formula for it, and I know what to do. I need to take all the X's times their frequencies, and then divide it by the total of the data points, the total of the frequencies. So for example, my first row is the ages 0 to 9. It has a frequency of 78. So that would be the 78 right there. That would be the F. But my problem is I don't have an X. I have a range of values. I have the range of values 0 to 9. Okay? And actually we account for this because if you look back up at how we define this, we said we're not finding the mean, we're saying we're approximating the mean. And the reason we're going to approximate it is because of the nature of a frequency distribution. This frequency distribution right here tells me that I have 78 individuals whose ages range somewhere between 0 and 9. I don't know what they are. So what I'm going to do is I'm going to estimate it by using midpoints. So I'm going to go through and find the midpoint. Now the midpoint of the first class is 4.5. If you're wondering how I found that, the midpoint is always the left endpoint plus the right endpoint divided by 2. So I would say 0 plus 9 divided by 2, that's 4.5. The second midpoint is going to be 14.5. Now I can either find that by doing the formula again and saying 10 plus 19 divided by 2, or since the class width here is 10, I can just add 10s straight down the list. And so then 24.5, and then 34.5, 44.5, 54.5, 64.5, 74.5, and 84.5. And there's my, I got a 94.5. Almost got away from me there. And so now I have X's and frequencies. And so if I wanted to, I could find the approximate mean by doing 4.5 times 78 plus 14.5 times 97 and so on and so forth, divided by the 78 plus the 97 plus the all the way down to that last pairing of the 15 people and all that. Now I'm not going to do that by hand because one, that's a lot of work, and I'm a huge fan of technology. So I'm going to chuck this one in my calculator. And so what I'm going to do is I'm going to take these midpoints that I just found and put those into my list 1. I'm going to take my frequencies, put those into list 2, and then basically redo the command I used up here. Okay? So let's go ahead and put that data in. I'll make that as big as possible. I'll grab my calculator, clear, stat, edit. I got a bunch of junk in there, so I'm going to clear it out. And so then this was 4.5, 14.5, 24. This is going to take a while. So I'm going to pause the video and come back with all that data put in. Okay, so I'm back. It was probably seamless for you, but I went through and I put all the data in, and I've checked it twice because there's a lot of data we put in here, and it's really, really easy to make a mistake. Now that I've got it all in, I'm going to say, oh, mighty gods of the TI, please find me. And so I went to stat, to calculate, to one variable stats. My data is in list 1. My frequencies are in list 2. Please calculate. And I get that the mean of this data set is approximately 42 point, and then round wherever they tell me to round it. I'm just going to call it 3, 42.3. And then these are years old because I think we're talking about a town here. So the mean of the ages of the people in the town is about 42.3. Now this is definitely an approximation because those are approximations. All those midpoints are approximations. All right, this brings us to the end of chapter, what is this? This was chapter 9, section 1. We'll come back and make some more videos for 9.2. See you then.